There we go. It should be, yeah. So there's a little button at the top so everybody can see it. So welcome to that. And so we're on Zoom, as you noticed. When you entered, you were muted, and that's just because most people forget they're muted. But this is an interactive discussion, so feel free to unmute yourself and talk, or type in the chat box or in the Google Notes. I think, like Ashwin and Christina and Peter and we talk to each other a lot, and I probably talk way too much. So the idea here is to get community input and let you know what's going on in the state of HPC carpentry. So what I want to do is, I guess, there's some slides to set the context. I wonder if the show of hands works. Who knows? Who's familiar with software and data carpentry? Is there lots of hands going up? Oh, there's little hands on the thing. Oh, good.
Where are the hand? Is there a hand up device on Zoom?
Yeah, if you go to the participants, if you click on the participants thing at the bottom, I think that's where you can find it.
Yeah, so down at the bottom, there's like a participants list, and then on the right, there's more. And
I found it.
Oh, good. Or you can just holler. So I'm wondering if anyone isn't familiar with carpentry. I guess that's a little harder to tell. No one now will admit it because there's so much peer pressure. So I think what we'll do first is introduce the discussion leaders, perhaps, yeah? And I guess I'll start since I'm already talking. So I'm Dana Brunson. I work at Oklahoma State University, and I basically am the conspirator of research computing here. I'm also the co-manager of the Exceed Campus Engagement Program, and that includes the Campus Champions, which is a whole nother passion of mine. And the reason I'm part of this is because I'm very enthusiastic about training novices using good teaching methods. And when I first learned about software carpentry, I was just blown away that people really thought hard about how best to teach and how to help people learn with, thinking about cognitive overload and, making it where they were able to learn things in a welcoming environment and all of those things that, if you've seen enough training as a math person, I learned a lot of the not good ways to teach. Okay, so Christina, do you want to go next?
Yeah, I can go. So hi, everyone. My name's Christina Cook. I think I've met quite a few of you either at conferences or over email or whatnot. So it's nice to see a lot of you again. And I'm situated at UW-Madison, University of Wisconsin-Madison, where I work for the Center for High Throughput Computing. And I support researchers who want to do large-scale computing both here at our center and just sort of generally on campus. And I'm currently on the steering committee for software carpentry. And yeah.
Great. Ashwin?
Hey everyone, my name is Ashwin Srinath. I am a research facilitator at Clemson University, South Carolina. I also inherited from Christina the role of maintainer for the software carpentry shell lessons. And I'm also an instructor for software carpentry, so I help out in software carpentry workshops both here at Clemson and other places.
And Peter.
Hello, everyone. This is Peter. Can you hear me?
Yes, we can.
So. Hi, I'm Peter. I'm calling from Dresden, Germany, over in Europe. And I'm a support person at an in-house core facility. We're helping our scientists here at the local life science institute to get their code running on the HPC infrastructure. And I've been introduced to software carpentry 5 years ago or something. And we've been teaching software carpentry courses here in the institute for quite a while now. And then I had this idea to transport all this knowledge to HPC. And here we are.
Awesome. Thank you. Okay, so I have some slides that I'm going to share. Let me see. I did. Here we go. All right. That should show up. What does everybody think? Can they see those?
Looks good.
Awesome.
Yeah, looks good.
I learned how to make PowerPoint not actually take up my entire screen. So that was my victory today. So first, to set a little context for software carpentry, and actually we didn't actually decide who was going to do the talking through this part. Christina, do you want to talk, or you want me to do the talking? You're muted.
I can talk
oh,
briefly.
Awesome.
Okay. Since I was the original creator of the slides. So yeah, most people raised their hands and said that they know a little bit about software data carpentry, but it might be helpful to just remind people of some of the main practices or parts of software and data carpentry, especially the ones that we think at least are relevant to bringing forward into an HPC carpentry-like training. And we'd be interested in getting everyone else's views on this as well. Because we've kicked around these ideas for a while, but it would definitely be good to get more input. So this will just be a quick kind of overview of some of the main driving forces, I guess, behind software and data carpentry. Dana, can you click forward?
I'm going to try. There we go.
Okay. So a very broad overview for people who aren't familiar with the organizations. Software and data carpentry are two formal organizations that are soon going to be one, but mostly community of people who participate in their activities, which include developing lesson materials, training people to teach workshops, and organizing workshops. And right now, those workshops cover either sort of data management or software development best practices, with the focus on research and the research community, and people who are sort of need these skills but have not gone through a specific training to do so sort of in any other way. Next. I need a little like Q button or something. And these really grew out of kind of like I mentioned, the fact that researchers were doing these things or needed to do these things. They had these piles of data they had to analyze. They have code and scripts that they inherit or they write themselves. But there was no formal structure in place to help them with that. And so the solution was this sort of 2-day workshop model with these collaborative community designed lessons taught by volunteer community members with an emphasis on best practice. And I think those of us who are really excited about HPC carpentry see the same kind of gap in people either need to be using or are using large-scale computing systems like clusters or distributed grids, but haven't gotten any real training and may not know what they're doing. So that's definitely been part of our motivation in thinking about HPC carpentry. So the Carpentries, both organizations teach skills, but I think just as important as skills, they teach best practices. So it's not just that you're learning how to program in Python, but hopefully you're also learning how to program cleanly or in a way that you'll be able to read after the fact or this kind of thing. And obviously with emphasis on the research audience. And so these are all things that I think will be important to think about if we want to develop a carpentry-like HPC training curriculum, especially that last one. Like, what do researchers really need? And how can we help them where they're at? Okay, so this is something that Dana alluded to earlier. Another big piece of the sort of Carpentries philosophy besides the content is the fact that it's taught using a lot of research-based pedagogical methods. A big part of that is hands-on stuff. So we would envision in HPC Carpentry definitely having, you would have access to some sort of cluster, large-scale system. There would be interactive exercises. The teacher would live code in front of the class, and there'd be mechanisms for feedback and a positive environment. Okay, so this can have a lot of different impacts. These are some of the ways that I've heard of sort of software and data carpentry communities having an impact on campuses or for the individuals who teach for them or attend the workshops. So some of these things might also be side effects of HPC Carpentry if we get it rolling. It kind of depends on what people invest in and what they want to get out of it. Okay, this kind of re-summarizes the first slide. There's lots of different ways to get involved. These are posted somewhere, right, Dana? Well, I guess I have them posted somewhere.
Yeah, I put a link to where you have them posted in the Google Doc.
So go ahead and skip through this one, this slide, and the next slide. Yeah, so if you're interested in more about software and data carpentry generally, definitely go back and check out the deck, and there's some places to get started. But this is where I think we really want to have a discussion today is, can we use this Carpentry's philosophy in developing HPC training materials? What would that look like? What are some of the challenges? Is there interest? What other wisdom can we gather from the community? Because a lot of people in this call have done training before. So I think learning from both your successes and your things you would do differently next time would be great. And then this slide also has links to the sort of work that's been done to this point, which is basically a very rough outline on GitHub and a mailing list, which hasn't been very busy yet, but we wanted to have a place where anyone who was interested could be on a list and you know where to go. So is that all the slides?
There's the usual the question slide and the icon credit slide, but
okay, that's it.
And also I should say that I put the links from this slide, the HPC slide, in the Google Doc. So so should I go ahead and shut down the slides and then we can
we can start discussing.
Awesome. Let me find the stop sharing button. There we go. Now I can see everybody again. Yay. Awesome. Thank you, Christina. So hopefully that helped with the people who are not familiar with the Carpentries and maybe got some more information for those who are. I know that here at Oklahoma State, we've joined as an institution, so we have a really lovely community built around the Carpentries, and are able to have workshops and train new instructors, and they meet together and help each other teach better. And so we keep thinking someday we'll run out of people that want to attend these workshops, but it hasn't happened yet. So let's see. So I think we want to open it up. So if you have some questions or comments about HPC Carpentry, now's a good time. If you've met me before, you know that if you don't talk, I might continue talking. I just want to say Ashwin and Christina and Peter, if you go to the GitHub repository, you'll see how much work that they have all put into this already. If you're not real familiar about how software carpentry lessons are developed, the magic happens at the repository. So if you go there and look at the issues tab, for instance, the real fun is to actually look at some of the history of it. So if you go back to the closed issues even, you can see some discussions from times past. And just to kind of give you one topic that that happened before is, like Christina said, we all, well, not everybody, but I think a lot of the people on the call probably do HPC training on their campuses or somewhere. And a lot of people do new user training all the way through teach MPI programming. And so one of the big misconceptions early on was to discuss who is the target audience for this HPC. And it's called HPC novice. So it was discussed a lot. And I think the idea here at the beginning is to develop the novice materials, because I think, this is all my opinion, but I think that the good research-based pedagogy is especially important when you're working with novices. So, raise your hand if your user base now consists of lots of people who haven't used computing before, right? So over the last, N years, we have a lot of life scientists who maybe never used the command line. So that's kind of that direction. So what do you think?
Well, I'll jump in, Dana.
Thanks.
So when we talk about a novice, we're probably talking about somebody who has done, let's take today's definition. I know everybody likes to say in 5 years, students won't remember what a laptop looks like. Everybody will be, let's assume you've got a laptop, Windows PC type person, right? They have a model in their head as to what a machine does and looks like. They know the difference between something that's stored on their hard disk versus something that's out on a website somewhere. They've built this model in their head. They may not even know it is there, but they have built it. If you take a look at a lot of OSC's entry-level training stuff, a lot of what we do is to try to give them a model for what a cluster looks like. The idea that it's lots and lots and lots of nodes that all see the same storage, that a process running on one node has nothing to do with a process running on another, and that everything that's done on these nodes is very automated and mechanized because it has to be. I was just curious coming into this discussion, very, very cold at this point. What with the tie and everything, all I do is I run a team I've got a team that does that now. So what are other people seeing in terms of the kind of model that you try to impart to your brand new trainees?
Somebody want to go ahead?
I was just going to say that's a great question, Dave. And if I see at least one hand up, B. Berkman. If people want to chime in, because I think this would be a really productive conversation, is thinking about what we assume our novice learner knows or doesn't know. Am I on a projection screen in there? Or this call?
You might be for some people.
I'm looking behind the person I just called on.
Brad?
Yeah.
Oh, yes. Brad has 5 students in there. Awesome. I was going to dig up the issue where reference already existing carpentry-like HPC novice lessons. So let me put that into the Google Doc. Because I think Dave and anyone else who has these materials developed, feel free to put links to them here.
Okay.
Or you can just paste them into the Google Doc.
Yeah. Returning to Dave's question, I would be interested in at least a couple people sharing what their sort of perception of a novice is, or if we say this is an HPC training for novices, kind of what you would expect them to have in their heads coming in and what you would want them to leave in terms of like a model of what's going on.
Hey, this is Henry. I
Hey,
would
Henry.
expect them to come in knowing how to use a completely irrelevant computing device, completely unrelated to HPC. I would expect them to know essentially nothing about command line, Linux, batch, remote, shared. They do not have that in their wheelhouse as a general rule. They are very comfortable on iOS, Android, maybe Windows or Mac OS. Now, obviously, there are always going to be exceptions to that, but a typical new HPC user is going to come from the background that I just described.
Okay, thanks, Henry. And I liked some of the words you used in there because I think those are big topics, but those are some of the models we then want to convey to people.
Yeah, I want to jump on Henry's point.
Concrete
too.
way. Yeah, go ahead, Dave.
It's students are used to their computing being local and interactive. And a lot of HPC workflow is remote and batch.
Yeah, it is literally, and it's shared instead of single user.
Yes.
It is literally the exact opposite of what their mental model of computing is. It's not just a matter of the exact opposite of what they're used to doing. It's the exact opposite of everything they've experienced about computing to date, with the possible exception of a multiplayer video game where they're really not aware of and aren't directly interacting with remote servers.
Yeah, great.
But, you know, Henry, do you think there's any value in unpacking those differences one piece at a time?
So my own experience has been that they are better served by walking through the process than they are by getting a lot of lecture. And I would imagine that this fits in better with the Carpentries approach anyway. The thing that we do, and I literally just did this last week at the Rocky Mountain conference at UC Boulder, is I hand them an exercise, and it's written out. And Dana has some helpful opinions on that aren't identical to mine, but these are good differences of opinion. Walking them through that process introduces them to most of these concepts, but I would not want to lecture them on these concepts, and I would not expect that to be effective.
Mm-hmm.
Yeah, so that's a great point, Henry, and you're exactly right. It dovetails with the sort of carpentry philosophy that you don't want to lecture people. You want to have them try it themselves and experience. But Dave, I think you ask a good question when you say, do you expose all these things at once? And I think the answer is definitely no. Maybe at the beginning, you help them think about all the things they do know, and that you're basically going to be upending them all over the course of the training. But obviously you wouldn't want to do that all at once. It's very overwhelming. And so helping people separate in their minds that a command line is not equivalent to, because that's the danger I think you run into, is people are like, a command line is the same thing as a cluster, is the same thing as batch submission. It's like, well, they are all.
I agree completely, and in fact, it goes even farther than that. So I teach programming for non-majors, and so we are using Linux command line. It is a remote system. It is shared, but it's not batch. It's all interactive.
Right.
And the way they use PuTTY in a sentence clearly indicates that they do not understand the distinction between the remote computer and the client that you use to access the remote computer, or between the client and the Unix shell. They absolutely do not understand those distinctions. They are entirely too subtle for someone who has not. I honestly think a big part of it is going on a tour and seeing one of these things. And my experience has been very much that if whatever the exercise is coupled with a tour, if you walk around inside a cluster, that is much more valuable conceptually than showing people pictures and trying to explain it.
Yeah, and that's also a great insight, Henry. We'll add that to the notes.
So,
I hadn't thought about adding a tool, like, I don't know, even like a little video tour to like a training could be like super useful. So I see Ashwin's hand, and there's some stuff going on in the chat. We'll try to get back to that as well. And I'm still interested in hearing what other people's opinions are about novices. So Ashwin, do you want to go ahead? And then.
Yeah, I just want to say that my recent experience has been that showing pictures is better than nothing, because that's what we were doing earlier. We didn't even have pictures in our HPC training, and I felt like that was a bad thing to do. So if you can't afford to take them on a tour, at least show them pictures. because I feel like that can be very valuable.
Awesome. Thanks, Ashwin. Dana, and then I don't know everybody's first names because they're not all down there, but Jay Wingard would be next.
I was just wondering if, since a lot of people are now familiar with Dropbox and Google Drive, if at least for the storage aspect of remote computing, I wonder if that's a way to tie in a metaphor to remoteness, or if that would confuse the matter more. I don't know.
It's Jane Weingart, University of Notre Dame. I like this idea of taking people on a tour. I do think that would help. I was just wondering, I agree with the definition so far of novice. So far, what we've done is we've used the existing software carpentry materials, so the existing intro to Bash and so forth. Do we need to have that in the HPC novice curriculum? I'm thinking it might help with this distinction if you introduce people to Bash completely independent of any kind of cluster concept, and then, and now we can use that in the cluster, perhaps.
I'll let Dana speak a little bit about this, because you've done this, right?
So we do a HPC undergrad honors add-on course, so it's no experience necessary whatsoever. And since we didn't have any material, what we did was use the software carpentry shell lesson, but we did it on the login node of the cluster. And I'm actually starting to rethink that a little bit, because I also want them to leave the class knowing they could actually do this on their laptops. But then at the end of the shell lesson, we go ahead and made Nell Nemo's 1,500 files and ran them in parallel on the cluster. And so they got to see, we developed, the work, we've tried to get across the workflow is you do interact when you're developing your workflow. But then once you have it figured out, and you need it to go through all your data for that kind of method, then that's when you send it off in batch. And so we attempted that. This is still a work in progress, so I can report back more later.
Yeah.
Thanks, that makes sense.
Yeah, and Jane, thanks. I think that's a good point. And one of the things that as I've been thinking about this HPC novice curriculum, I think the first question, one of the major challenges is figuring out what order to teach things in. So there's an order right now in the lesson that we've proposed, but I think it's kind of flexible. So if you wanted to just teach about the shell for the morning so that people really got that this was its own interface, basically, and then in the afternoon transition to what it means to run things on a cluster, I would love to see people try it different ways and kind of see how their students react. Not that we could do formal research on this. Because someone made a point earlier in the Google Doc about maybe introducing modules before you submit jobs. And you might have to. And that's a thing that hopefully, if this develops into a real curriculum, we can kind of rearrange things.
Can I make a couple comments about that based on what we've done? One is I genuinely believe, based on a lot of years of teaching, that whatever you show them in the first 5 minutes is what they think it is for the first 5 years. So you have to be very careful what you show them up front. What I show them up front, and I'm happy to share the document that we use to walk people through this. What I show them up front is an actual workflow, a toy job to be sure, but an actual workflow that's reasonably realistic for how you would use a cluster. I don't show them running a bunch of jobs in parallel non-batch, because if I do that, I've just taught them that that's okay. And on most HPC clusters, if you run a bunch of stuff interactively on the login node, you're going to get hate mail. And it's not that those little jobs would generate hate mail. It's that once they've got that in their head that that's okay, they're going to run big jobs that way. And then they're going to get hate mail. And I don't want to generate extra hate mail for my own team.
Well, I don't know. Yeah, we should maybe clarify about what kind of interaction on the login node. I agree completely that teaching them bad habits and training is a bad idea. Right? I think that's probably nothing we would ever argue about. but I think people do edit files on the login node. And
Right, and showing them that
create
behavior as
directory.
part of the workflow, I think, is a terrific idea, and we do that. But showing them running a job interactively, I think, is a mistake.
The other thing we do is kind of vignettes. This is what we started last semester, is after the shell lesson, which we consider, you know, a biological goo vignette. Then we did a genome assembly vignette. So we did the entire workflow of from when they get the data to assemble a genome and then look at the data. Even though they don't, you know, we tried to find science examples that were easy enough to explain to freshmen that hadn't, you know, but everybody watches CSI, so they know what that is. And then we had a computational chemistry with some funny water. We had an actual chemist come in and explain that. And then we're developing one for crop modeling. So that way they at least get kind of 4 examples, because it's hard. I think the hard part is not only what a novice is, but it's, you don't want to overload them with everything they need, you know, everything everybody ever needs to know about HPC. You want to, at least I want them to know enough to be successful in their research. And
I agree 100%.
And keep it to that, right? Just because I think Linux permissions are so fascinating, and 90% of our users never need to know those things exist. So it is, again, how much do researchers need to know is kind of the other end of the question, from what's a novice to how much do they need to know.
Randy from Colby, can you talk a little bit about what you just put into the chat and how you've approached HPC training via domains? You have to unmute yourself.
Sure, I was just extending on what Dana said. It is really more successful, for me at least, with novice, the most illiterate of the HPC people, to give them very specific tasks that are related to their research needs. Then they'll extend that on their own. If I sit them down and explain to them what Slurm is and what the Unix shell is, they lose it inside of 2 months.
Yeah, so really tying everything back to
What they do.
They do and will be useful to them and they understand. Yeah. Do you have like an example of like a domain that you've targeted this way?
RNA-seq assembly work.
Okay, cool. I see Jane's hand and, oh, more hands. Hey, and Aaron. I think Aaron's above. I don't know if that's because it's alphabetical order or not. Go ahead.
Hey, I was just going to make a note about the interactive versus batch. One thing that we found with our training is that often the moment you take away the interactivity, there's a fair amount of the students either losing interest or losing excitement with what's going on. And that's, you know, I hear the point and I take it well about batch being more important to teach because it's more likely what they're going to actually be doing. But often what we'll do is at a small scale or even off of the cluster, we'll kind of introduce some of the concepts in a very highly interactive way so that they're not feeling like they're hitting enter and then checking out for a few minutes and then coming back later.
Okay, thanks. I think Jane was up as well.
Just to speak to the domain training, so I've actually only been involved specifically in training polar scientists. And what we've settled on eventually after a couple of events is we make people propose a project and they come as a team. And the project obviously should be what they're working on in their everyday work. And then we run the training and then have 2 days of hackathon per se where tutors are available. So they've come with a problem that they need to deal with. They're running it on their laptops right now. There's also a lot of dev work still done in terms of, you know, maybe you're still tuning your algorithm or whatever. And obviously when you introduce them to various ideas of parallelism, that could change hugely. But yeah, it's just the idea of tying the same carpentry model of training, interactive and everything that it is wonderful at, and then having dedicated time, like days with tutors in place to help with the getting onto the cluster and all that.
Yeah. Okay, I see, and I'm looking at people trying to keep up with comments in the chat too. Thank you all. And so, Shelley, do you want to talk a little bit about your approach at Colorado?
Sure. Yeah. So we've developed. It's called the Basics of Supercomputing, and it's a 2-day workshop, and we've done it 3 times now. And we're definitely trying to hit the newbies. So we say, the only thing you need to know to come in is to be able to turn on a computer. And we teach Linux, and we use, well, it depends on who's teaching it, but sometimes we use the software carpentry lesson. We teach modules, software installation, job submission, computing architecture, because a lot of people don't understand what, we can talk about all these processors and cores and they don't really grasp what that means, or memory or things like that. And then we jump into some basics of parallelism. And I've stolen some of, with credit, of course, Henry's slides from the Supercomputing in Plain English. And then at the very end, we teach them, usually OpenMP, and by teach, I mean, we show them some code and just sort of what it looks like so they can kind of grasp what parallelism means. And we do these, and they're about 1.5 hour chunks or so, depending on the topic. And it seems to be going pretty well. I mean, we've made a few adjustments since we did the first one about a year ago, but people seem to like it, and they're always filled.
Cool, thanks. So that's an example of a little bit more of a general approach, so you can hit as many people as possible, right?
Right, yeah.
Yeah. Okay, cool. Yeah, I think there's definitely merits to both. Challenges trying to figure out which one will work best for your campus and kind of just what you want to do. Okay. You revisit. So that's a lot of helpful thoughts, everyone. I think we all have around the same idea of what a novice is, but what may differ is sort of our ideas of what is most important for people to know, especially in a domain-specific context. And then I think once you have that laid out, how to get them there is a little clearer. But that goal can be the challenging part. And I think what would be great is if we had a curriculum that is sort of flexible, where you could go, where each, I guess, piece of the workshop lesson is standalone enough that you can do some mixing and matching and pick the pieces that seem most relevant to whatever it is, whatever goal it is you're trying to achieve. So again, that theme of flexibility, I don't know how we're going to do that, but I think that's the goal. Yeah, anyone have any other thoughts about sort of the models that novices come in with, or that they need when they leave, or techniques or tips or experiences to share kind of in this space? I see Henry's hand. Go ahead.
So I assume they come in with nothing other than they can use email and buy stuff off Amazon. So they are comfortable with machines, but they have no exposure to the 5 things I rattled off before. I assume that their tolerance for spending time learning it is low. We try and make sure we can wrap it up in about an hour, even if that means they take some homework with them. I don't try and teach in a big group. I don't try and teach domain-specific stuff. We'll just take a toy problem. I want them to walk through the experience of submitting a batch job, checking whether it's done running. Eventually, they get the little email or whatever. I want them to go through that experience. And then I work from the assumption that at their home institution, someone is going to have to show them how to run the specific thing they want to run in the specific way they want to run it. It's not possible to cover that in a group class, especially if that group class includes people from multiple institutions, which was the case last week. So they're going to have to go meet with someone at their institution to get their institution's way of doing it, because that may not be Slurm, and so on and so forth. If you're teaching a specific domain at a specific institution, you can obviously delve a lot deeper. But even then, even within a domain, there's going to be lots of different codes within that domain, and perhaps many of the people at the workshop, a specific code will not be relevant for, but the experience will be. So, and I want them to come out able to run a batch job and able to go learn how to run the batch job they actually want to run.
Sounds good. That was a nice summary. Thank you, Henry. Other thoughts? I think as I put into the chat and Dana mentioned before, people have put these trainings and things together, and there's an issue on the GitHub repository to collect them. And please, if you have materials you can share, put them in there, because I think the more examples we have to look at, possibly the better. Maybe not, maybe information overload, but I think just having all these things in one place will be helpful, just so we know what people have done. So I've seen a couple things in the chat that are obstacles, I guess. I don't know if it's worth spending a little time talking about this. This could turn into a very long conversation. But someone mentioned, command line is a challenge to people. Text editors can be a challenge. Aaron just put in that, using a specific software package, in this case, R packages. So I don't know if that's worth discussing, or if people want to just throw into the Google Docs some challenges that have come up in. Yeah, Dana, you're muted.
I guess, I don't know, I'm not seeing too many people chime up on that one, but I have a burning question.
Oh, please, ask away.
I'm curious if we could build a consensus on what people need to know, right? I think we've covered it kind of in the what is a novice by all the things they don't know, right? But what is really the minimum thing somebody needs to know to use remote batch computing, right? Ashwin, go for it.
They need to know how to manage files and folders via a command line. They need to know how to use the command line the same way they use their file browser to move files around, rename them, copy them, delete them. So that's one aspect of using the command line. And I feel like they need to know what happens when they enter a command. They need to know that the shell is just a way for them to run programs. They're used to double-clicking on icons to run programs and then using buttons and text boxes to control them. But they need to know that the shell can be used to do the same thing. And preferably, they need to use the same program two ways, via the command line and via the graphical interface. And they need to see that these two things really do the same thing. They need to understand what the advantage of using the command line for that is. And I think these two things, just learning how to manage files and folders and learning what happens when you use the command line to control a program, I think that's a good enough start for most people to understand how cluster computing works. Then they can start learning about what the HPC system looks like, which programs can be used to submit jobs to it, and so on and so forth. But these are the core concepts that I feel a lot of people miss when they maybe learn Linux on their own. But it's really all there is to know about using the command line, at least for novices.
Thanks, Ashwin. That was very eloquent. I think you're exactly right. So Susan has asked an interesting question. Is the goal A, to get their work done, or B, to understand broad HPC basics? I have my opinions about this. And it kind of is alluded to in Jane's comment in the chat about intro material showing the big picture, how different problems map to different programming models types. And I think this may be something people will not agree on, but I think that gets at that same question. Are you just giving people kind of steps to follow? How much of the big picture, how much of the concepts are you trying to teach them alongside? Because looking at Susan's comment, when I see is the goal is to get work done is more of kind of a step-based thing, and understanding broad HPC basics, which I take to mean submission on a shared remote system, not parallel programming. Is a different thing. So I'll let Henry start, and then if other folks can chime in as well on what you see as important in the balance of getting work done versus understanding HPC basics.
In my experience, the overwhelming majority of them look at HPC as exclusively a tool and not a thing of interest in itself. They no better understand why we go to a conference on supercomputing than they understand why anyone would go to a conference about hammers. Yes, we may have an amazing hammer. It may be the highest quality hammer. It may be able to do amazing hammering that no other hammer in the world can do. They totally don't care. It's still a tool. It is not interesting to them in and of itself. All they want to know is how to get their work done. And I'll be honest and say, as much as I love HPC, which is a lot, I am very sympathetic to that point of view. They do not have time to screw around. All they need now, over time, they will come to be more interested in the stuff that helps them get their work done. And some of that stuff will be broader HPC content, if you want. But up front, for that introduction, they totally don't care. They just want to get the damn thing done.
All right. So I'll push back a little bit on Henry's comment and say, what if people need help choosing a hammer versus a screwdriver as the correct tool to solve their problem?
I think you're totally right, and helping them do that is an important part of the job.
Yeah. Okay. Other thoughts on? It seems, I feel like most of the things I've seen is most researchers seem to be just motivated in getting their work done. And
but can I, Christina?
Yeah.
Just a quick comment on this. I mean, the overall idea behind software carpentry was always to be incremental. I think one of the key issues why we're discussing what does a novice need to know or whatnot is always that we actually targeting novices. We don't want to make them experts in HPC right away. We want them to give a chance, have it interactively, namely mentoring in front of a class, because they're in the class voluntarily and want to know this stuff because they want to solve a problem. So I think that's a big danger with many HPC materials that I've seen, is that you want to, we say in German, screw the big screws, like right from the start, right? So, yeah.
Yeah, thanks, Peter. So to return to Dana's original question, if we're thinking people just want to get their work done, what do they need to know? What do they need to know to use the tool? Okay, so we have from Aaron, they need to know how to run a program in parallel? Like from the command line?
Right. They need to start with at least being able to, control how many cores they're running with, manage the resources they want to be able to run their program. They don't necessarily need to know right away how the program is written in parallel. That can come later. And they also need to be able to analyze how quickly their program is running. So gathering runtime data and hopefully seeing examples where there's always a limit. If all you care about is speeding up your program, there's always a limit to how many chords you can add. It's not just, add as many as you want and you'll always speed up.
Right. Thanks, Aaron. Other things people should know, Dana?
Well, I mean, I think Ashwin and I still think covered it quite well as far as interacting with the command line. And I always usually start my initial lesson with typing PWD, because I start with who am I as their first command, and the most important question is where am I, right? Because if you can figure that out, half of using the command line is solved. But like, I'll push back on Aaron a little bit though, because I think some of our users never really need to learn the parallel part even. They're using a code that maybe is a lot of serial jobs that they're doing parameter sweeps on. So our vignettes, we try to hit each of those, like you're running single core jobs, but whole bunches of them, or shared memory jobs, or distributed memory jobs. We don't say it like that to them, of course. But that comes in kind of the what is this machine type of thing, and part of, there's different kinds of hammers, but it's hard to tell. I think maybe just covering that, there's different kinds of applications that use the HPC system in different ways, and that's the key. The researcher needs to find out, or with your help, figure it out. But we don't have very many people that do programming or really understand parallelism. The ones that do use programs that use distributed programming, well, these days they're often joining a research group that teaches them what they need to know, because a lot of times choosing those things are beyond the scope of a novice anyway.
Yeah. Thanks, Dana. I see Blake Sand.
Hi, my name is Blake. I work at Cyverse, and so we spend a lot of time thinking about, we're an NSF-funded program that helps life scientists and other kinds of scientists access bigger compute. So we kind of look at the national and international scale of things. And we've done a lot of work with HPC, and that's why I'm here. I'm really interested in bringing that dynamic of how do you take local HPCs and then move users to those, but also move them up bigger to like national exceed level HPCs or otherwise. And the one thing I would mention, I have to go in just a bit, but I'd love to see a section, and this is maybe something I can help with, so I'm not volunteering someone else. I'd love to see a section on containers, like Singularity or otherwise. And I know that's going to cause lots of political whatever, but I found that when it comes to life scientists anyway, being able to leverage an HPC and then leave that HPC environment to go somewhere else but use the same commands is really, really useful for people. And at that point, it doesn't matter if you need a hammer or a screwdriver. They're familiar with the hammer and the screwdriver, and then it becomes a lot easier. And I know that I think you guys are also thinking of doing like cloud carpentry and cyber carpentry and some other things. And so I think that having some of that kind of tie all of these disparate systems together may be a really useful thing. And I'd be happy to help with that. I just taught a kind of a 2-day course called Journey to the Compute, where we just moved around to different systems and executed Hello World and other things. But I'd like to formalize it. So anywho, I'll just throw that out there. I didn't mean to interrupt the other conversation.
I think that's awesome.
You're here.
Yeah, so I know it's 1 minute till the end of the hour, so we should adjourn. This has been a great discussion. I think we could go on for several more hours easily, because I've already thought of several more questions that this group would be great at discussing. Any last words from Christina or Ashwin or Peter? I know, Christina, you have to go quickly. Ashwin, all right. I'll make them.
Well, if I may,
Please.
I think it's very important to collect. I think it's very important to collect all this feedback, because as we saw during the discussion, the balance is the most critical to get. And we have so many use cases, so many domains. They all need to use these big beasts. And teaching that is hard. We will not accomplish that like in a year's time or so. So that's why. So thanks to you all for your feedback.
Thanks. And I think the beauty of the style of development in GitHub with Markdown means that whatever is developed can be then continuously adapted and evolve as needs and technologies change. So thank you, everyone. This is great. Watch the repo for new stuff and join the mailing list. And thanks, Christina. You're awesome. And Ashwin and Peter and everybody. All right, we'll sign off now. Thanks.
Goodbye.
Bye.